Okay, now let's look at an example with flux. Now let's look at an example with flux. First, let's remember how we can write flux in terms of a work integral. So the flux of a function f is the work integral on its perpendicular f perp right here, which is a perpendicular vector rotated counterclockwise. So, quick check here. If f equals little f and little g, then f perpendicular is negative g f. That's the way we worked through the process in class. Let's look at if f equals ur. X, Y. Oh, we know what UR is right there. And F perpendicular equals, well, we're going to swap the components and negate the second one as it comes. And when we rotate the radial direction, we get the angular direction, which makes sense. We have the radial direction, we rotate 9 degrees to the right, we get the angular direction. If we rotate again from theta, we get to the negative radial direction. If we rotate the negative radial direction, we get the negative angular direction. So it's a nice little rotation by 90 degrees. So for our field, our cyclone here, our typhoon, we get minus r, the same scalar multiple, doesn't change, and we get u sub theta, because the radial direction rotates to the angular direction. And then plus 1 over r, and u sub theta rotates to minus u sub r. The negative radial direction, or inward direction. Oh, and I need that perpendicular there, make sure we have that. So now, flux of f equals the work integral all the way around for some closed curve of f perpendicular dotted with dr equals. Okay, well, what's our curve going all the way around? That is a circle of radius 2. So we move around using the angle theta from 0 to 2 pi. Our perpendicular field is minus 1 over r theta plus, it's a minus 1 over r again, ur, and we dot that with dr. dr for moving around is r d theta in the theta direction. So, let's remind ourselves that ur dotted with u theta, the radial and angular directions dot to 0, and u theta and u theta dot to 1, which gives us integral from 0 to pi of what's left? Well, there's a negative 1 over r multiplied by r. That's a negative d theta. Sorry, negative 1 d theta. And if we integrate out, that's just a constant, we get a negative 2 pi. So the flux coming out of this typhoon is negative. Why? Because the typhoon is pulling in. It makes sense that the flux is negative because it's pulling in the air molecules all around it. So if you pick a circle around that type, the flux is inward. It is negative all the way around. Okay, that wraps up our work and flux examples in polar.